In this lesson, you will learn how to work with the vertex form of a quadratic function. You will need the provided graph sheet as well as a sheet of notebook paper. Let's go ahead and look at vertex form. It's f of x equals a times x minus h, and that is squared, plus k, where the vertex is the hk ordered pair. So let's talk about some details of that vertex form. So again, let's write it out. So vertex form, we have f of x equals a times x minus h, and that is squared, plus k. If we're going to find our vertex, we use the hk value. Well, notice in vertex form, it has a minus sign. Most times when we see a minus sign, we give the value to the number that's with it. However, because vertex form says that it needs a minus, this h value, we will actually write down the opposite of what we see. So if you see a minus 4, your h value is 4. But if you see a plus 9, your h value would really be a negative 9. For the k value, you will write down exactly what you see. So in order to find your vertex, you just will look at your hk to write your ordered pair. Notice this is not like standard form where you have the A, B, and C. So that means we cannot use the axis of symmetry formula because we don't have the values in order to plug in and solve for the axis of symmetry. You can actually make a note that the axis of symmetry is going to be the same as your h value. So our axis of symmetry, we will not need a formula for vertex form because our x will be the same as our h value. Let's look at some examples. We have y equals 2 times the parentheses x minus 6 squared minus 7. Let's name our vertex. So again, we're going to take our hk, our h value is a 6, and our k is negative 7. And we have our vertex. If you needed to know your axis symmetry, it would be 6. Let's go ahead and talk about whether this vertex would be a maximum or minimum. You still go and look at your a value. So because that a value is positive, so a equaling a positive number, our graph will open up, meaning that that vertex is the lowest point. It's a minimum. So here we're going to have a minimum at the y value, so at negative 7. Let's look at example number 2. Again, we have a problem at y minus 4 equals negative 7 times x plus 2 quantity squared. Notice this one is not quite in vertex form just yet. It looks pretty close. We've got a number with a parentheses squared. However, the y is not by itself. So let's solve for y. When you solve for y, you'll actually just add that 4 at the end. It cannot add with this negative 7. This negative 7 will represent our a value. So we'll need to tack on that plus 4 at the end. So we'll have y equals negative 7 times x plus 2 quantity squared, and then our plus 4. So let's name our vertex. So our vertex will be our HK point. Notice here we see a positive 2, so we'll write down -2. You want to take the opposite of what you see so that it will match the actual vertex form. It needs to say -h, and we don't have that. In order to have a minus sign, you would really have a negative. Minus a negative is the same as plus a positive. So now our K value, we take exactly what we see, so +4. Let's talk about that vertex as a max or a minimum. We said that if A was positive, we had a minimum. So if A is negative, that means that graph will open down, pointing to the negatives, and we will have a maximum. That vertex point is the highest point on the graph. That means here, with our A value, we have a -7, so that makes us have a maximum value at our Y number, so at 4. Let's look at example number 3. We're going to have Y equals x squared minus 8x plus 9. Notice this is actually standard form. So we're going to have to learn to change the standard form to vertex form. In order to do so, you'll rewrite the problem with blanks. So Y equals x squared minus 8x. You'll say plus a blank, and then move that 9 out of the way, and then do minus a blank. We're going to do a process called completing the square in order to fill in this blank, and we need to add and subtract the same number to complete the square so that we still have an equation that's equal. So in order to find the value that completes the square, you're going to take half of your b, so your b value, and divide it by 2, and you're going to square it. And that will go in both blanks, half of your b and square it. So let's do that. Our b value is -8. So half of that is -4. Let me go ahead and do the half of the b squared. Let me go ahead and put the exponent on there also. So let's go again. Half of -8 is -4, and then we're going to square that, and it gives us +16. Be careful when you're squaring negatives. You have to have parentheses, so especially if you're typing that in. So our value for our blank will be 16. Let's fill that in. So y equals x squared minus 8x. We're going to add that 16, and we're going to subtract that 16. Remember, just keeping our equation equal, we have to add and subtract the same number. It's making it look different, but the value of this equation has not changed. So these first 3 terms are now a perfect square trinomial. We have completed the square to make it a perfect square trinomial. So we can rewrite those in 1 parentheses squared, like we need for vertex form. We need 1 parentheses squared. So this becomes our x in the first term. And to get your second term in the parentheses, you're going to have the half of your b, and you don't have to square it this time, so just the half of b number will go in your parentheses. And then to get your k value at the end, you're going to combine the 2 numbers that you have at the end of your equation. So those become that k value, the plus k. So let's solve that for this equation. Our first 3 terms become 1 parentheses squared, and we'll take half of our b. Well, we had that from earlier, so that's the -4. If half of your b is a +7, you would write +7. Now we combine these numbers. 9 take away 16. That's where we get -7. So this is our equation now in vertex form. Let's name our vertex. Our vertex, we take the opposite of our h, and we take exactly what we need for our k. We can still look at our a value to see if this will be a max or min. Here the a value is a 1, so that means this graph will open up. Because that a value is positive, our graph will be opening up, and that vertex is the lowest point. So it's going to be a minimum at -7. Let's take a look at another example, changing it from standard form to vertex form. So we have y equals x squared plus 14x plus 57. So we're going to change this from standard form to vertex form. So rewrite it with plus and a minus blank. So x squared plus 14x, we're going to do our plus a blank, scooting over that 57. Don't lose the 57, it's part of your equation. And then we have to do minus blank. To fill in the blanks, we're going to take half of your b value and square it. That's what fills in the blanks. So our b value is 14. We're going to divide that by 2 and square it. 14 divided by 2 is 7, and 7 squared is 49. So that goes in our blanks. The first 3 terms are now a perfect square trinomial. So that means we can rewrite it. Those 3 terms all become 1 parentheses squared. So these 3 things right here are being replaced with this binomial squared. In order to find your binomial squared, you take x and then half of your b. Half of 14 we said was 7, and it is a positive 7, so we will need a plus sign. 57 minus 49, when you solve that, 57 minus 49, we get 8, so that's the plus a number at the end. You combine these like terms in order to get the number at the end. So now we can name our vertex. We use our h, k, again being very careful with our h, writing down the opposite number, and then for k we write down the exact value. Because our a is 1, this graph will open up. That positive 1 will make it open up, and so we have a minimum at the value of 8. You could always use your graphing calculator to check that your equations were equal. So let's take a look at that before we start graphing vertex form. So hit the y equals button. You can type in the original equation that was in standard form. So x squared plus 14x plus 57. And then in the second equation, type in the vertex form. So parentheses, x plus 7, close parentheses and square it, plus 8. If we're going to say that these are equal, they should give us the same values in the table. So we're going to go to second table and scroll up and down. It's probably best to look at your vertex so you can start seeing that quadratic pattern. We said that our vertex was -7, -8, and we see that both with the standard form equation and the vertex form equation. And all of our numbers throughout the table match. So that's a great way to check your standard form with your vertex form. So let's move on and start graphing these. So for our vertex form, we're going to start by naming our vertex, and then we're able to go and put that in our table. We do not have to do any work to find axis of symmetry because when we have it in vertex form, our axis of symmetry is the same as our h value. So example number 5, we have 7 plus y equals 2 times x minus 6, and that is squared. So first, we have to get this in vertex form by solving for y. Let's subtract 7 on both sides. Remember, that just gets tacked on to the end. It will not combine with this a value. That minus 7 will become our h. So we have y equals 2 times x minus 6 squared minus 7. So we'll need to name our vertex so that we can begin graphing. Our h will be 6, our k will be negative 7, and we take and plug that into the center of our table. Make 5 ordered pairs and put your vertex in the middle because it's the middle of their parabola. So 6, negative 7 is our vertex. You'll need 2 numbers less than and 2 numbers greater than that vertex. The y values, you can either calculate those y values by plugging in 4 here to your equation and working it out. And you'll do that for each value of the table, or go to your graphing calculator. So in your graphing calculator, press the y equals button. Of course, clear out anything that you have in there. We're going to want to type in the equation that's in vertex form. So hit 2 parentheses, x minus 6, close parentheses and square it, and minus 7. So that is in vertex form. We type that exact function in our equation. So second table, you scroll up and down until you find the ordered pair that you say is the vertex. At this very moment, you should be able to see if you're on the right track. Because if we say the vertex is 6, negative 7, we should see that written in our calculator. So the rest of the values we can copy for our y column. 1, negative 5. Of course, we have the negative 7, negative 5, and 1. And now we will plot these points. So we have 4, 1, 5, negative 5, 6, negative 7, 7, negative 5, and 8, positive 1. Noticing this parabola makes that mirror image with the axis of symmetry being our symmetrical line down the center. So draw in that axis of symmetry. It's a dashed line at x equals 6, the same value of your x of the vertex, and then the vertex is here at 6, negative 7. Let's finish up by talking about the domain and range. Hopefully by now you're noticing that all quadratics will have the domain of all real numbers. Here along the x-axis, eventually we will reach every single x value. So in interval notation, we write that negative infinity to infinity for all real numbers. Remembering to keep that least to greatest. So let's talk about our range. We notice that our vertex here had the lowest point on the graph. So because we want least to greatest, that value, which is at negative 7, will come first to be least to greatest. And then our y values continue on forever out to infinity. Of course, the infinity symbol has a parenthesis around it. And with the negative 7, because there's a point there at the vertex, we will want to include that value, so we put a bracket. Let's look at one more graphing for vertex form. So we have y minus 6 equals negative parentheses x plus 3, quantity squared, minus 8. So again, this almost vertex form, but noticing that it's not solved for y, before you get started, make sure you solve for y first. So we'll add 6 to both sides, lining it up with the like term. So we get y equals negative x plus 3 squared, and negative 8 plus 6 gives us negative 2. So our vertex for this equation, we're going to take our h, k, so for our h, write down the opposite of what you see, and k, write down exactly what you see. And put that vertex in the center of your table. You'll need 5 ordered pairs, and that vertex is at the center of the parabola, so we put in the center of our table. You'll need 2 numbers less than and 2 numbers greater than your x value of your vertex. So come up with 2 numbers less and 2 numbers greater, and then from there you've got to calculate and solve for the y's. You can do that on your own using the equation, or calculate with the calculator using the table feature. So let's go back to y equals and clear out what we have. Let's type in the equation in vertex form. So we have negative parentheses x plus 3, close parentheses and square it, and then minus 2. Always being careful, exactly what you have as your equation is what you've typed into the calculator. If you go second table, you can find your table of values. So scroll up and down whichever direction you need to go to find the values that you need. We say that our vertex is at negative 3, negative 2, and that's exactly what we find in here. If in our y equals, maybe we forgot to type in that negative in the front, notice what happens when we go to our table. We said that our vertex was negative 3. Oh no, it does still give you, oh yes, because everything else. This is a kind of tricky example to realize. This vertex would still be at negative 3, negative 2. The thing you'll miss is the opening up or opening down. So that is not a good way to show you a mistake, because it still would give you the same values. But maybe if you made that a plus 2 at the end, let's look at that. So if you accidentally typed in plus 2, see that that does give you a different vertex. So let's make it what we need. We need a minus 2. And second table, those are the ordered pairs. So negative 5, we'll have negative 6, negative 4, negative 3, negative 2, negative 3, and negative 1, negative 6. The thing about it is, always make sure when you go to y equals, you type in the exact function you need to graph, or else the calculator does not know what values to calculate with. Let's graph this parabola. So negative 5, negative 6. Negative 4, negative 3, negative 3, negative 2, and negative 2, negative 3, and finally negative 1, negative 6. Connect those to make a smooth curved line. It does make that U shape. And notice it does open down. If we would have accidentally left out the negative, hopefully you're paying attention, because this is an A value that's negative, it is opening down. Our axis of symmetry is here at x equals negative 3, and our vertex point is at negative 3, negative 2. So everything is lining up for this equation. So finally, let's look at our domain and range. Domain, again, will be negative infinity to infinity. That is true for all quadratics. So our range, when we look here, the highest our graph reaches is at negative 2. So that is not the smallest, so that's our highest number. If negative 2 is the highest number, it goes on the right-hand side of your range. The lowest that the graph reaches is negative infinity. So that gets a parentheses. Our negative 2 gets the bracket because there's a point including that value.